Have you ever imagined that with every step we take in our day, we can produce energy for the surrounding things? Good day, we are team number 4 and the name of our prototype is Kinetic Floors. During this video, we will explain the functionality of our project, among other things. The objective of our prototype during this stage is to show its feasibility and its 100% functionality, in addition to being able to measure its variables. It is important to mention that our project is highly related to UNESCO goal number 7, affordable and clean energy, since our idea has the function of contributing to the different solutions against the indiscriminate use of non-renewable energy and its negative effects on the environment.
Now I'm going to explain the hypothesis. Through the creation of our project, we have the hypothesis or prediction that we can convert kinetic energy to electrical energy through the use of different components such as piezoelectrics. We believe that the greater weight we exert on the plane, the more energy we're going to obtain. And finally, in this video, we will be able to check it out in its totality.
This is our prototype and I will explain its functioning. Let's remember that the piezoelectrics are the part fundamental of our project, and when we press it, the energy is created and the multimeter measures it.
So now I will explain the collected data of the experiment and why it increased exponentially. All these values are just approximatives. First, in our prototype, we use 10 piezoelectrics. Every single one generates about 2 volts. Then, the voltage per step is around 20 volts, meaning that if we give 2 steps, the volts are gonna be 40. Now, the amperes per step are 0.07. That means if we give 2 steps, the amperes are gonna be 0.14.
Now I'm going to explain the variables of our project, and the main variables we need to consider are the amount of steps we apply to the kinetic floor and as its result the amount of voltage. As it was explained on the last part of the video on the table, we get an approximate amount of voltage for every single step we did, and with this we can have a greater idea about the effectiveness of our product. So on the next part of the video we will explain our mathematical model, and the variables we use are the voltage and the money, the amount of money we can save if we use these kinetic plates on school or in every single place that we can use it.
I'm going to explain the mathematical model for the stem. So we need to do some assumptions. But well, first, using our data collected in the previous steps, we have an approximate of 20 volts and 0.07 amperes. 1 watt is equivalent to 1 volt multiplied by an ampere. So if we multiply the 20 volts times the 0.07 amperes, we have 1.4 watts. This equals to 1.4 to 10 to the minus 3 kilowatts. And if we multiply that to the 27 steps that is in the stair of the school, that means 0.038 kilowatts for going up. And if we add going down, we have 0.075 kilowatts. So if we multiply that by 700 students, we have 53.2 kilowatts. That is all the energy produced when all the students go up and down. That happens 3 times per day minimum, that is in the break, in the entrance, and in the exit. So this translates to 160 pesos saved per day. And if we multiply that by the 20 days that we come from to school, that equals 3,200 pesos saved per month. And we can use this data to graph them as month and money saved. And I use 3.2 instead of 3,200 because it's more easy to visualize in the graph. And here it is. And now, okay, it might seem like a small number, but it's still money saved. And in the long term, it seems more significant, in addition to the fact that it's clean energy. If we do the same process and operation and functioning in bigger places or places like a main avenue or where many people travel, the profit will be much, much bigger.